A small piece of an old spacecraft slams into a satellite and shreds it into thousands of pieces. Those pieces start hitting other satellites. Every crash creates even more debris, like a chain reaction. Then, the International Space Station gets taken out. No one survives. The collisions keep snowballing until Earth's orbit is so clogged with junk that half the satellites stop working. GPS starts failing and internet connections drop. It's also impossible to launch new spacecraft without them being destroyed. We'd be trapped on Earth for decades, maybe even centuries. This nightmare scenario has a name: the Kessler effect, and new calculations suggest we could be just a couple of days away from it. This idea was first proposed by NASA scientists back in 1978. It describes a situation where low Earth orbit gets so crowded with man-made junk that objects start crashing into each other. Each crash creates more fragments, which leads to even more crashes over time. The amount of space junk can grow faster and faster. Scientists still argue about this theory. Some think this scenario wouldn't be as dangerous as predicted. Others think the Kessler effect may have already begun. We just don't see it yet. But one thing is clear: space junk is a real concern as Earth's orbit gets more crowded every year. There are almost 17,000 satellites in space right now, counting the ones that don't work anymore. And they can get dangerously close to each other more often than most people think. The crowding up there can be a nightmare. Satellite operators can get a dozen or more alerts a day about possible collisions. A close approach is when two satellites pass within less than about 0.6 miles of each other. That happens about once every 22 seconds. Within the Starlink network alone, it happens roughly every 11 minutes. To avoid collisions, each Starlink satellite makes an average of about 41 course corrections per year. But not everything up there is tracked and cataloged. According to statistical models, there could be over 141 million small pieces of space junk orbiting Earth right now. Things like pieces of old spacecraft, tiny flecks of paint, and leftover rocket parts. All this junk moves incredibly fast, up to about 18,000 miles per hour, which is more than 30 times faster than a commercial jet. Most of it is out of our control, so sooner or later, collisions happen. Since 1957, there have been more than 650 blasts, collisions, and other events that created more fragments. This means the Kessler effect is very much possible. Simulations suggest that within a few decades, collisions in space could become the main source of new junk. And this could still happen even if we stopped all launches today, which honestly isn't gonna happen. Scientists then decided to see how fast this whole situation could spiral into disaster. So they came up with a new measure called the Collision Realization and Significant Harm Clock. Thanks to that, they found that if we completely lose control of satellite avoidance maneuvers, it could take only about 2 to 3 days for a catastrophic collision to happen, one big enough to kick off the whole Kessler effect. Now, you're probably hoping all that space junk just disappears, right? I know, me too. But it's not that simple. The fastest way it disappears is when it re-enters Earth's atmosphere and burns up, like a man-made meteor. But how long that drop takes depends a lot on how high up it is. At around 300 miles up, objects in orbit will naturally fall back to Earth or burn up in the atmosphere within about 25 years. So junk at that height usually wouldn't block our access to space. But as you go higher, the problem gets worse. At nearly 500 miles, it can take at least a century for debris to get pulled down naturally. Above about 620 miles, it can take thousands of years. And that's a problem because the region up to 1,200 miles is the most crowded. It's packed with important satellites. Some of them provide internet, like SpaceX's Starlink. Others track the weather, observe crops, and study Earth's climate. So, if a Kessler-style chain reaction starts up there, it's a big deal. That junk would stay up there for a long time and we wouldn't have an easy way to clean it up. That would make life down here a lot harder. It would disrupt the internet and GPS and cause major communication outages that could last a long time. Then we have another problem. Not all space junk burns up when it comes back down. Sometimes about 40% of the object's mass survives and hits the ground. And this is big. One day you could be on a flight when out of nowhere a piece of an old satellite falls out of the sky and hits your plane. Each year there's about a 26% chance that space debris will pass through some of the world's busiest airspace, like the northeastern United States or northern Europe. The chance of it actually hitting a plane is small, sure, but the stakes are high because a single impact could put hundreds of lives at risk. Up in space, debris can be dangerous for astronauts on the International Space Station too. A large hit could puncture part of the station, depressurize a section, and force the crew into emergency mode to try to get home. Astronauts are pretty exposed up there, and one sudden collision could turn everything into a fight for survival. So, here's the weird part. If there are millions of fast-moving pieces up there, how is the ISS still in one piece? Well, it does get hit sometimes, but not as often as you might think. In 2021, a piece of space debris struck the ISS and damaged one of its robotic arms. All 7 astronauts on board were safe, but the impact was still pretty scary. They couldn't predict it because some objects are just too small to track. When the danger is bigger and we can see it coming, the crew has to maneuver the ISS to stay out of the way, but that only happens once or twice a year. And yeah, that sounds strange. Countries have blown up satellites in space. Companies are launching mega constellations with thousands of new satellites. Millions of pieces of junk are flying around Earth for years, and yet the International Space Station hasn't been destroyed. What are the odds, right? This is the other side of the story. Some experts think that even if a Kessler-style event happens, it might not be as apocalyptic as people imagine. I mean, we wouldn't be locked in on Earth as the theory suggests. According to these experts, a crewed spacecraft heading into deep space would still pass through the riskiest part of orbit really fast. So it might not be that bad. But one thing almost everyone agrees on is that the whole chain reaction is very possible. Is there a way to avoid the Kessler effect? Well, it's hard to say. Some think it's already too late to stop it completely, but 2 things can help. First, making new rules and regulations. For years, space policy experts have pushed for international guidelines to keep companies from adding more junk to orbit. Second, developing cleanup technology. Companies and space agencies are working on ways to pull debris out of orbit. For example, the European Space Agency developed something called the Drag Augmentation Deorbiting Subsystem, or ADIO. It's basically like a cool parachute in space. When it deploys, it increases the satellite's surface area, which creates more drag. That makes the satellite slow down, drop into lower orbit, and eventually re-enter the atmosphere, so it burns up instead of just floating around up there for years. This is just one of many ideas scientists are testing to deal with space junk. The hope is that before things get worse, we'll figure out more efficient ways to clean up our orbit. There's a mysterious dent in our planet's magnetic field, and it's slowly growing. It stretches from South America to Africa, and what's horrifying is that it's weakening Earth's protection shield against the sun. They call it the South Atlantic anomaly. And while most people on Earth don't feel its effects for now, satellites and spacecraft passing through it already do. Deep inside our planet, there's a giant ball of molten iron and nickel, the outer core. The metal inside is so hot that it's constantly moving and swirling. This movement creates electrical currents, and when electricity flows, it generates a magnetic field. This field surrounds the entire planet like a protective bubble. Without it, life on Earth would be in serious trouble. The sun blasts out charged particles called solar winds that could destroy our atmosphere over time. Luckily, the magnetic field deflects most of these particles, keeping us safe. Other planets without magnetic fields like Mars lost their magnetic fields, got their atmospheres stripped away, leaving them dry and lifeless. And also, without the magnetic field, our technology and equipment gets all messed up. Satellites, power grids, and even airplanes could get hit by intense radiation. This would lead to communication failures, GPS errors, and blackouts. And now, something strange has been going on underneath the African continent. An enormous blob of dense rock deep inside the Earth, called the African Large Low Shear Velocity Province, has been growing and messing the magnetic field up. Scientists think that this weird rock-like thing is messing with the flow of the outer core, disturbing the magnetic field above it. That disturbance is what weakens the shield over the South Atlantic. It's like a crack in a windshield. It might not shatter immediately, but the weak spot spreads over time. Now, NASA is watching it closely. Satellites passing through this anomaly experience random glitches and shutdowns. Sometimes their circuits short-circuit from high-energy solar particles. Mission operators have to turn off systems before entering the danger zone, and it's only getting worse. The anomaly is drifting westward. This means that new areas could fall under its influence. What's even worse, it seems like it's been splitting in two, which means our planet has been developing two weak spots instead of one. And here's something crazy. Some scientists believe that this entire thing is part of a long-term cycle that's been repeating for over 11 million years. And that cycle would make our magnetic poles flip. North could literally become south, and vice versa. Earth's magnetic poles have flipped before, although the last time that happened was 780,000 years ago, way before humans started roaming around the planet. These reversals happen every few 100,000 years. Now, some wonder if our anomaly is the beginning of the next flip, but scientists aren't sure if we're overdue or just in a temporary phase. Luckily, if a flip were to happen, it wouldn't be instant. It would take thousands of years. But as the field weakens, more radiation would reach Earth's surface. It would mess up not just technology and equipment, but also us, and even animal migration patterns. Many animal species use Earth's magnetic field to navigate. And they even have some potential culprits that could have caused this weird thing. There are two massive, mysterious blobs of hot, dense material deep inside our planet. One is under Africa, and the other formed under the Pacific Ocean. They're called large, low-velocity provinces. Basically, huge underground rock-like formations. Both blobs are gigantic. Each one is hundreds of times taller than Mount Everest and stretches across thousands of miles. They make up 6% of the entire Earth's volume and are one of the biggest geological features inside our planet. They're also super weird and could be structured more like trees than some lumpy mountains. Scientists imagined them as softened rock at first, but based on recent imaging techniques, it looks like they might actually have jagged, branch-like structures extending upward. These are like branches of a tree. They could be feeding hotspot volcanoes at the surface, like the ones in Hawaii. Scientists still don't know exactly what these blobs are. However, they believe they control a lot of what happens on Earth's surface. Stuff like volcanic eruptions, earthquakes, and, of course, changes in the magnetic field. They may also be linked to supervolcanoes and mass extinctions. The eruptions that they could cause could be like the ones that happened in ancient times and possibly wiped out entire species. If the blobs are connected to supervolcanoes, they might have had absolutely insane disasters in the past. and might even cause more troubles in the future. But they also help us control plate tectonics, which affect earthquakes and mountain formation. They might also contain material from Earth's early days, or even from Theia. That was the mysterious planet that crashed into Earth and helped form the Moon about 4.5 billion years ago. Finally, Earth literally breathes because of these blobs, which is insane. The Sun and the Moon's gravitational pull stretches the Earth slightly, making it rise and fall like a breath. But now, scientists found that this tidal movement is slightly off-kilter over the blobs. They literally interfere with how the Earth's mantle moves. These two huge structures actually actively affect how our planet behaves, which is super dangerous. We only recently learned how these blobs actually appeared on our Earth. It's all because of the sunken ocean crust. Over hundreds of millions of years, parts of the ocean floor have sunk deep into the Earth's mantle. These slabs of rock stacked up at the bottom. This way, they slowly formed these massive blobs of recycled crust. Scientists haven't agreed on whether the blobs are heavier or lighter than the rest of the mantle. One study suggested they are denser, which would mean they're made of heavier material. Another study suggested they are less dense, meaning they could be hot, rising plumes of lighter rock. The African blob is suspected to be one of the causes of the South Atlantic anomaly, but scientists are still investigating how exactly they are connected. Since the African blob is basically a giant dense blob sitting on top of the outer core, it could cause troubles. The African blob is hotter and possibly chemically different from the surrounding mantle. It could be disturbing the outer core, affecting the magnetic field, weakening it. Another crazy thing is that they might contain an ocean of water locked inside their minerals. Scientists discovered that huge amounts of water, as much as all of Earth's oceans combined, are trapped in minerals deep in the mantle. One mineral, ringwoodite, can store water inside its crystal structure, but it's only possible under extreme pressure and super hot temperatures, like in the deep mantle. So there could be vast hidden water reservoirs inside the blobs. Not literal bodies of water, of course, but tons of little water molecules weirdly locked away deep beneath the surface. If this water were somehow released, it could potentially trigger massive volcanic activity, or even affect global climate. But the blobs are not the only factor for this weird anomaly. Other factors also contribute, like the tilt of Earth's magnetic field, changes in the core's iron flow, and even plate tectonics. However, the large provinces are making things worse. They keep evolving somehow. Scientists think that it might be because massive columns of hot rock called mantle plumes are rising from deep inside the Earth. These plumes could be pushing the giant pieces of Earth's crust like tectonic plates around, especially in the Pacific Ocean. If this is true, then these giant underground blobs aren't just sitting still. They're moving, changing, and shaping the Earth's surface all the time, almost like they're alive. So what does this mean for the future? If the African blob continues evolving, the South Atlantic anomaly might get larger or shift further, affecting more satellites and spacecraft. Right now, there are still more questions than answers. Every new data point helps predict how it will evolve and whether we need to worry about the worst-case scenarios. For now, NASA isn't panicking, but they're watching very closely. Because whether it's a harmless shift or a sign of something bigger, one thing is clear: something deep inside Earth is changing. Space junk enters Earth's atmosphere almost every day. Specialists from Earth track most of it. Around 400 such incidents happen every year, but not all space debris can be tracked. Some fragments of satellites may fall to the ground. That would give us meteor showers every night. Junk falling from the sky develops huge speed, which implies severe destruction. Fortunately, none of this really happens. Very few people had the chance to observe the falling space debris. There were almost no cases in history when fallen satellites damaged someone else's property. To find out what happens to space objects during the fall, you'd need to understand how they managed to fly around Earth for so long. Imagine you work for the Meteorological Service. Today, you're launching a satellite into Earth's orbit to monitor the climate of the planet. The satellite is installed on a rocket. The rocket takes off and reaches the speed of 25,000 miles per hour. This is faster than the speed of a bullet and the speed of sound. This acceleration is necessary for the satellite to overcome the gravitational attraction of the planet. As soon as the satellite goes into space, into the upper atmosphere, the rocket simply falls off. But it's given the satellite the necessary speed and energy to make its motion possible. This movement is called momentum. The satellite is located at an altitude of thousands of miles from Earth, but still, gravity pulls it down. Momentum and gravitational forces make the satellite fly in a circular trajectory around the planet. This trajectory is called an orbit. At this speed, the satellite could move further into outer space, but the force of gravity pulls it down. Our meteorological satellite is balancing between these two forces, and it's quite difficult to find this balance. The closer the satellite is to the planet, the stronger the effect of gravity. To stay in such an orbit, the satellite must fly very fast. Here's our satellite entering orbit and developing incredibly fast speed. And now you can see one of the reasons for its failure. Thousands of other space objects are flying past the satellite at the same speed. The slightest collision can lead to devastating consequences. Currently, about 500,000 pieces of space junk are flying around Earth. These can be small pieces, the size of a tennis ball, or huge ones, the size of a subway car or a bus. There are also tiny fragments of satellites. If two pieces of spacecraft collide with each other, they fly apart into thousands of small segments. The number of them can reach up to 170 million. The planet's orbit is filled with unnecessary debris rushing at great speed. Most of them are tiny, the size of a grain of sugar, but they are no less destructive than the decommissioned segments of rockets that deliver satellites into orbit. For example, a single drop of paint can damage a spacecraft if it's flying at 30,000 miles per hour. To avoid this, engineers calculate the routes of satellites they launch in advance. They also cover it with a strong protective layer of various metals. The more orbital debris flies around the planet, the more accidents happen. And the more accidents happen, the more orbital junk appears. This is an endless circle. But scientists try to develop strategies to clean up Earth's orbit. The next cause of accidents is the Sun. Our star is constantly releasing high-energy particles. These particles collide with everything that gets in their way. And when they crash into satellites, they can change their trajectory and slow down momentum. There's a shield in the upper layers of the atmosphere, the Earth's magnetic field. Satellites fly inside this shield. The field reflects solar radiation from the planet, but there are places on Earth where this shield is weaker, and when satellites fly past such spots, they receive a large amount of radiation. It disables navigation and the stable operation of all systems. Fortunately, accidents caused by solar radiation are rare. Another reason is the change in the gravitational field of Earth. Our planet is in motion. Its internal processes can change the shape of the gravitational field. These changes can disrupt the satellite's flight path around the orbit. Fortunately, such gravity failures are insignificant. They can only cause the satellite to fall after a few years. And the most important reason why satellites fall is people disconnecting them. If a satellite can no longer transmit data or is outdated, specialists simply make it fall. Another common reason is the lack of fuel. If the satellite runs out of it, it's impossible to control it. It turns into a senselessly flying object. That's why experts use the remaining fuel to slow down the satellite and bring it out of orbit. Scientists plan such operations well. They stop the satellite at a certain moment so it can fall over deserted areas of the oceans. The satellite falls and passes through Earth's atmosphere at great speed. The lower layers create strong pressure and friction on space junk. These processes generate a huge amount of heat. The satellite catches fire and falls apart. Most of it simply burns. The remaining debris falls in remote places of the planet. This method works when the satellite is flying close to Earth. Some space objects are located far from the planet. The Earth's magnetic field is much weaker there. In such cases, it's easier to use the remaining fuel to go beyond the gravitational force. They just send a satellite to float into outer space. Pieces of rockets, large metal remnants of old satellites, and other debris can't be controlled. All these pieces fall into the atmosphere of the planet and turn into ash. The smaller the falling object is, the fewer chances it has to reach the ground. Big junk can survive in the atmosphere. Fortunately, such objects are monitored by special services. When an old satellite enters Earth's orbit, people already know in advance where it will land. And if someone is in this territory, they will be evacuated. But this happens quite rarely. People only use a small percentage of the total land area for living. More than 70% of the planet is covered with water. If the atmosphere can't burn space debris, then water will destroy it. Space objects either fall into the ocean or in sparsely populated areas of Earth. The probability of a satellite hitting someone's house is really small. But if that happens, then, according to the law, the house owner will be compensated for the damage. Whatever country you live in, the company that built the fallen satellite will be to blame. This company is obliged to pay all losses. Falling space junk has its favorite location on our planet. This place is even called the Satellite Cemetery. Point Nemo is a conditional spot in the world ocean, the most distance from any land on Earth. It's very difficult to get there, and it's not much easier to get out. If you find yourself in this place, you need to sail more than 1,000 miles to get to the nearest island. Moreover, the distance to the International Space Station from this place is smaller than to the nearest land. If you suddenly find yourself on a ship at Point Nemo and you run out of fuel and don't have a radio, then you need to think about what signal to send to the sky. Astronauts from the ISS may notice you and inform the Coast Guard of your location. Almost no ships sail here. That's why all companies throw their satellites away in this place. The blast wave, the force of the impact from the junk, will dissolve in the boundless ocean. The bottom of this place is covered with space debris. Falling satellites do no harm to sea creatures. Point Nemo is one of the most lifeless places in the world. Cold, nutrient-rich water doesn't get here. There's hardly any wind that's carrying a lot of organic substances through the ocean. In simple words, there's no necessary amount of food for the development of large life forms. Right now, satellites are falling in Point Nemo and slowly sinking to the seabed.
Did you know that the moon is rusting? No, not rustic, rusting. Well, that sounds impossible because rust needs oxygen, and the moon, well, it doesn't have it. Or so we thought. Apparently, Earth is leaking its air, and it's marinating the moon. It might have been like that for billions of years. What does this mean? And why do scientists say it's great news for a future lunar base? Well, let's find out. A few years ago, the Indian Space Research Organization sent a probe called Chandrayaan-1 to orbit the moon. Its mission was to take some nice pictures, but it also was carrying a NASA-built instrument designed to chemically map the surface. The readings came back showing something scientists didn't expect on the moon: hematite. It's an iron oxide, or in plain words, rust. It's the same red, rusty material that eats through your garden fence or a forgotten bicycle chain. Finding rust on Earth is normal because our planet is wet and airy. You need a strict recipe to make it happen. You need iron, you need water, and you need oxygen. The Moon already has the first ingredient for rust because its surface is rich in iron from billions of years of asteroid impacts. But the other two ingredients are missing. There is no atmosphere to provide oxygen, and there is no liquid water gathering on the surface. But it goes beyond that. Space actually hates rust. The Sun constantly blasts the Moon with the solar wind, a stream of fast particles made mostly of hydrogen. Well, these particles tend to strip oxygen away from rocks instead of adding it. All of that makes it obvious why hematite doesn't belong anywhere near our satellite. But these results don't lie. The presence of hematite means that somehow, despite the vacuum and the Sun's particle stream, the Moon is getting a steady supply of oxygen. It's not coming from deep space or the lunar core. Also, the rust isn't spread evenly. The data showed that the hematite is more concentrated on the side of the Moon that faces Earth. The far side is mostly clean. Now, the only oxidizer close enough to do the job is Earth. We learned at school that Earth's atmosphere ends at the Kármán line, about 62 miles up. That's where space officially begins. But that's just the thick part. In reality, Earth is wrapped in a gigantic invisible cloud of hydrogen called the geocorona. It's enormous. It glows in ultraviolet light, and it stretches almost 400,000 miles into space. That's farther than the Moon's orbit. This means that despite being very far away, the Moon is still within the outer edges of Earth's atmosphere. If you were standing on the Moon, looking back at Earth with a telescope that can see ultraviolet hydrogen, Earth wouldn't look like a blue marble. It would look like it's wearing a huge, fuzzy, glowing halo. Now, when we picture Earth and the Moon, we imagine a huge, clean gap between them. Two worlds separated by nothing. But that nothing isn't actually empty. The two are already connected by gravity, tugging on each other nonstop. But there's another kind of connection most people never think about. Earth is surrounded by an invisible force called a magnetic field. It's created deep inside the planet and stretches far out into space. We don't see it, but it's the reason compasses work and the Sun doesn't strip our atmosphere away. This magnetic field doesn't just stop at Earth's surface. It doesn't sit there like a perfect bubble either. The solar wind pushes on it non-stop, stretching it out behind Earth into a long magnetic tail that reaches hundreds of thousands of miles into space, like a tail trailing behind a moving comet. That tail is how Earth's oxygen ends up on the Moon. The Sun slams into Earth's upper atmosphere, knocking oxygen and nitrogen atoms loose and turning them into charged particles. Normally, they'd drift off into space, but because they're charged, Earth's magnetic field grabs them and sends them backward, down the magnetic tail. Most of the time, the Moon is off to the side doing its own thing. But once a month, right around the full moon, it slides straight into Earth's magnetic ponytail. Inside that tail, Earth blocks the harsh solar wind and gives the Moon a few days of calm. But it's still moving straight through particles leaking from Earth. Those particles collide with the surface and react with the iron in the soil. Repeat that long enough, and it adds up. Earth loses tiny traces of its air, and the Moon quietly collects them, using its weak gravity like a slow, patient net. It's like driving behind a dirty truck. Dirt flies off of it, but you don't really notice until it starts sticking to your windshield. The same thing happens on the Moon, except, no windshield. We actually have proof of this happening in real time. A Japanese probe called Kaguya was hanging out in lunar orbit, and its sensors spiked when the Moon passed through Earth's magnetic tail. It detected a surge of high-energy oxygen ions. Scientists call it the Earth wind. It acts like the solar wind, except instead of being hot particles from a star, it's made from leftovers of our own atmosphere. And this suddenly makes the Moon part of a much bigger story. Scientists think this kind of atmospheric escape can help explain what happened to planets like Mars. The red planet doesn't have a global magnetic field today. but long ago it probably did. When that shield failed, its atmosphere had a much easier time leaking away. Studying Earth and the Moon is like watching a version of that process on replay, just in slow motion. And it's not unique. Near the edge of the solar system, Pluto's thin atmosphere is slowly being stolen by its moon Charon. Ooh, larceny in space. Pluto's gravity is so weak that its atmosphere stretches far into space. When those gas particles drift close enough, Charon's gravity simply grabs them. No magnetic field needed, just a leaky planet and a nearby moon pulling the material away. Now, when the Apollo astronauts brought lunar soil to Earth, it was already loaded with hydrogen from the solar wind. The sun sprays the lunar surface with hydrogen, and over time, that hydrogen gets baked straight into the dust. That's the H, but you still need the O2 to create water. The regolith may already contain trace amounts of oxygen locked into minerals and dust, not as ice, but as something that can potentially be processed. It would mean that regolith is not just a nuisance that destroys gear and rovers. For a future lunar base, even small amounts matter. Water is heavy. Launching it from Earth is a nightmare. If the moon can supply even part of what astronauts need, it could make a difference. Now, another cool side effect of this discovery is that drilling into the moon could tell us more about Earth's history. You see, our planet is terrible at keeping records. It's like a giant recycling machine. It's always changing. Tectonic plates grind the crust down and melt it into magma. Winds and rains erode rocks. The air that we breathe now is different from the one that was around 2 billion years ago. Now, we can guess what the ancient atmosphere was like, but we don't have a physical sample. The moon is the complete opposite. It's cold and static. When those Earth particles land on the moon, they get buried under dust and stay there. They're trapped in the crystal lattice of the soil. Think of the lunar surface like an ice core in Antarctica. The deeper we dig, the further back in time we go. If we drill a core sample on the moon, we might, theoretically, find layers of oxygen and nitrogen from 2.5 billion years ago. That is right around the Great Oxidation event, when microbes first started pumping oxygen into our atmosphere. That could tell us something we don't know. It could prove that life started earlier than we thought. It could show us exactly how a dead planet turns into a living one. That's another answer you can give the next time somebody asks why we should go back to the moon. Also define the green cheese. Hey, just Google it. You know, we've all begged for just 1 extra hour in the day. Actually, 2 hours would be better. Well, scientists have good news and bad news. The good news is that our planet is heading toward a future where a day could last 25 hours. The bad news is that eventually, the same physics that makes the day longer will also get rid of our planet's rotation, literally freezing Earth in time. Meaning endless days and nights and oceans fleeing to the poles, all while the atmosphere turns into a relentless planet-wide storm. Uh-oh. Now, back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that debris smashed together, it started to swirl, like water rushing down a drain, but on a cosmic scale. That spin caused a momentum. Since space is a vacuum, there was no air to slow us down. Earth just kept spinning, and that spin became a day. One full rotation takes about 24 hours, and that's the rhythm we've known since we started recording time. But the thing is, we adopted 24 hours as a close estimate. In truth, a day is never exactly 24 hours long. Now, basically, Earth keeps spinning, but it's constantly losing tiny bits of speed. That's mostly because mass keeps moving around. Think of it like a figure skater. If they pull their arms in, they speed up. If they put them out, they slow down. Earth does the same thing, except without arms. When the 2011 earthquake hit Japan, it shifted the ocean floor so violently that it pulled Earth's mass inward, instantly shorting our day by 1.8 microseconds. Conversely, as glaciers melt and water rushes from the poles to the equator, Earth's arms are spreading out, causing us to drag. We're not just sitting on a big rock. It's like we're on a wobbly spinning top that moves every time something heavy happens on it. Most days end up being a few milliseconds longer than 24 hours. We can't feel this, but atomic clocks can measure it. Over long periods of time, those milliseconds add up, and as they do, the length of a day slowly increases. That's how a 24-hour day starts drifting toward 25. To check this, scientists pulled together nearly 3,000 years of sky records. Thousands of years ago, people carefully recorded eclipses. It was a scary event. Kings, priests, and astronomers wrote the exact time and location when the sun vanished. Those records survived on clay tablets, scrolls, and manuscripts. For the sky to go dark, the sun, earth, and moon must line up perfectly. If the timing is off by even a second, the shadow falls on the wrong part of the world. Today, astronomers know the moon's movements with incredible precision. They actually bounce lasers off mirrors left on the lunar surface to measure its orbit. That's why, in theory, we should be able to rewind the past like in a YouTube video and see every ancient eclipse exactly where history records it. But when scientists tried that, the moon showed up too early, or too late. The shadow wasn't where the record said it should be. The puzzle only solves itself when you realize one thing: Earth used to be a little faster. When researchers adjust Earth's rotation to be slightly quicker, everything snaps into place. In other words, Earth was spinning a little faster in the past, and these eclipse records show it. On average, this translates to a day increasing by about 1 to 2 milliseconds every 100 years. That's 1,000th of a second. You'll never notice it. But over time, those tiny bits stack up. About a second every 10,000 years. That means we are roughly only 200 million years away from having that one additional hour of sleep. So the good news turns out to be only meaningful for future Earthlings. But why is this actually happening? Well, the answer is the moon. Its gravity grabs Earth's oceans and stretches them into huge tidal bulges. But because Earth spins much faster than the moon moves around us, those bulges don't sit neatly under the moon. They get dragged slightly ahead as the planet rotates. That means the oceans are constantly being dragged across the planet, rubbing against the seafloor and the continents. That rubbing creates friction, and friction is a thief. Where there's friction, there's heat. So the moon slowly turns Earth's spin into heat that spreads through the oceans and into space. And once that energy is gone, it's gone for good. Since there's no visible cosmic creature to push Earth back up to speed, day after day, the moon acts like a slow, steady brake, stretching our days little by little and drifting farther away as it does. Yes, as much as we used to fear that the moon would collide with Earth one day, it's actually going in the opposite direction. All that transfer of energy that's happening between Earth and the moon is slowly pushing our satellite further away, approximately 1.5 inches per year. We know this because during the Apollo missions, astronauts left mirrors on the moon's surface, and today scientists fire lasers at those mirrors and time how long it takes the light to come back. However, even though we are slowly pushing the moon away, don't panic. It's not packing its bags just yet. At the current rate, it would take tens of billions of years for the moon to retreat significantly. But it will stick around long enough to witness and maybe even cause the end of all ends, so to speak. The same braking force that is slowing us down now could eventually push Earth into a state called tidal locking. This has actually already happened to the moon. You know how we never see the dark side of the moon from Earth? Well, that's because Earth's gravity grabbed the moon eons ago and forced its rotation to stop relative to us. Well, if you give it enough time, the universe could return the favor. If Earth slows down enough to match its orbit around the Sun, the cycle of day and night will disappear. We could turn into what astronomers call an eyeball planet. Because the Sun would just hang motionless in the sky, the side facing it would turn into a blistering scorched desert. That's the pupil of the eye. The side facing away would freeze into a massive white shell of ice, the white of the eye. The only spot where life could hang on in this area is called the iris. a narrow strip caught between the crazy hot day and the frozen night. But even that wouldn't be a dream come true. You'd have super hot air on one side smashing into freezing air on the other. So this zone would be hit by insane hurricane-level winds whipping across the surface. Also, without Earth's spin shaping the oceans, water would slowly migrate away from the hot regions and collect in colder zones, reshaping coastlines and continents entirely. The planet wouldn't just have longer days. It wouldn't even look like Earth anymore. But here is the bright side. We will actually never see this happen, and neither will our descendants, at least not while watching from nearby. The math says it would take about 50 billion years for Earth to stop spinning and turn into that frozen eyeball fully. But our Sun doesn't have that kind of time. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant, swallowing the inner planets and likely vaporizing Earth entirely. Bye-bye! So, while Earth is slowing down, it will never actually get to zero. We won't end as a frozen, motionless rock. We'll end as we started, space dust. By the time Earth ever stops spinning, humans certainly won't be watching from the solar system. We might be scattered across the galaxy, living in space, or not even human anymore. Some of us could live inside massive structures built around stars, capturing their energy instead of orbiting them. Others might drift near black holes, using their gravity and energy in ways we barely understand today. Entire civilizations could exist as uploaded minds, connected through a galaxy-wide network, living in simulations instead of physical worlds. Well, wherever we are, Earth would just be an old planet concluding its story. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our Sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, super-hot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the Rosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the Sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the Sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the Sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the Sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the Sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the Sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the Sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the Sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more. Sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.
A mysterious space visitor has recently passed its closest approach to Earth, flying by at a distance of 64 million miles. It might be something totally natural and born on the outskirts of the solar system, or some unknown civilization could be examining us from above right at this moment. This new object looks a lot like another strange wanderer called 3I Atlas, and you'll understand why we say strange pretty soon. So, could both of them come from the same place outside our solar system? What we do know is that this new object is relatively close to us, in space terms of course, and scientists are now studying it closely. They first spotted it inside our solar system, and people are paying attention because it showed up not long after 3I Atlas passed near our Sun. On November 2, 2025, astronomer Gennady Borisov, the same person who discovered interstellar comet 2I Borisov in 2019, found this new object. It's now got its official name and is listed in NASA's and the Minor Planet Center's databases. C2025V1 has some unusual features. Its orbit is tilted 113 degrees, which means it's moving almost up and over the regular path that planets take. Even more bizarre, its orbital plane is almost at a right angle to the path of 3I Atlas. Plus, it doesn't have a clear comet tail, which is odd. Right now, its orbit has an eccentricity of 1.0095. And let me break it down in human language. If that number was well above 1, it would mean the object definitely came from outside the solar system. But because it's only just a bit above 1, the most likely explanation is that C2025V1 came from the Oort cloud. That's a giant faraway shell of icy objects that surrounds the solar system. Now scientists checked this by basically rewinding the object's path, sending it all the way back to about 1000 AU. That's 1,000 times farther than the Earth is from the Sun. At that huge distance, the planets can't mess with its motion anymore. When they redo the orbit from that point, its eccentricity, the number that tells you if it's from outside the solar system, usually drops below 1, which means it's still part of our solar system. But at the same time, even a tiny push from Jupiter while passing by could make even a normal Oort cloud comet look like it has an eccentricity slightly above 1. And on top of that, small blasts of gas coming off the comet's surface can also change the numbers a little. So, to put it simply, it probably isn't interstellar. It just looks that way because of small pushes and gas bursts. C2025V1 is still exciting, even if it comes from the Oort cloud, because studying it gives us a chance to analyze the material from that distant region and learn how our solar system formed and evolved. Now, let's get back to the mystery of 3I Atlas. Before anything else, let's explain what 3I Atlas actually is. It's most likely a comet, basically a huge, dirty snowball flying through space. You can't see it with your own eyes or with a regular telescope. But there's good news. A powerful telescope in Italy is streaming it live for free. So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That number is hard to imagine, so here are a few comparisons. The Eiffel Tower weighs around 10,000 tons. So 33 billion tons is the same as a whopping 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. But even all that size isn't the wildest part. Some experts think this object might be a piece of unknown technology from outside our galaxy. And they're not saying this just for fun. There are real reasons behind the theory. 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS. Shortly after, NASA confirmed that the object wasn't from our solar system at all. It's an interstellar object, only the third ever discovered. The first one was Oumuamua in 2017, which looked long and flat and didn't behave like a normal rock. The second was Comet BI Borisov in 2019. Now we have 3I Atlas, and it is enormous compared with the other two. Its nucleus is up to 3.5 miles wide, while Oumuamua was only about a quarter mile long, and Borisov was around a half mile across. Besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and gas. This suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the other two known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. And unlike objects in our solar system, which followed curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. These odd behaviors have led some researchers to consider a pretty unexpected idea. 3I Atlas might be a probe sent by another civilization, possibly to study Earth. According to this theory, the object could be a sign of some kind of intelligence from beyond our solar system. Why do they think this? Well, because the object's movement doesn't match what you'd expect from something controlled only by gravity. It also passes close to Venus, Mars, and Jupiter. And these are the planets that might be especially interesting for an outside civilization to observe. Another very unusual feature of 3I Atlas's path is that its orbit is tilted only a little compared to the plane of the solar system, about 5 degrees, and it moves in the opposite direction to most planets. This feature might allow the object, or its creators, to take extremely precise measurements of planets, things like their orbits and sizes, to plan a perfect flight route through the solar system. And if 3I Atlas suddenly changes direction at some point, that could mean it's using a built-in engine instead of simply drifting through space. Now, new photos have also shown that 3I Atlas has at least 7 jets blasting material into space, some shooting in totally opposite directions. Now, if this thing is just a normal comet, it would have had to lose a huge amount of its original mass when it passed near the Sun, way more than just 10 to 20%. Only some of that material would actually push the object in one direction, so the total amount blown off would need to be massive. If that's what happened, then there should be now a giant cloud of gas and dust around 3I Atlas. And if that cloud exists, it'll be pretty easy to figure out what the comet is made of. The James Webb Space Telescope will check this when 3I Atlas gets closest to Earth on December 19, 2025. But if 3I Atlas is not a normal comet and is actually some kind of technology, it wouldn't need to lose that much material. Engines built by an advanced civilization could give it a boost while using way less gas because they shoot it out way faster. Faster exhaust gives more push with less fuel, so a technological object wouldn't need to blast away big chunks of itself the way a natural comet would. So, to sum it up, there's still a big mystery around 3I Atlas. Could it really be a technological mothership that released small probes into the inner solar system? But C-2025 V1 doesn't fit that idea, unless one of the objects used some kind of engine. The closest their orbits ever come is about 46 million miles, and the two objects themselves were never closer to each other than about 140 million miles. The tiny, non-gravitational push, detected in 3i Atlas, is nowhere near strong enough to close this gap. So, C-2025 is almost certainly not one of the many probes people imagine 3i Atlas might have released. For the last few decades, Earth has had an interesting coincidence. The northern and southern hemispheres have reflected almost the same exact amount of sunlight back into space, but new data from NASA shows that this symmetry is collapsing. The planet is becoming lopsided in a way we haven't measured before. Why is this happening? And will it change the weather we rely on? Well, let's talk about that. If you tear the map in half at the equator, you get two drastically different pieces. The northern hemisphere is the crowded side, having around 68% of Earth's landmass. It has massive continents of North America, Europe and Asia, the sands of the Sahara, and the snows of the Himalayas. The southern hemisphere is the complete opposite. It is a water world. Aside from Antarctica and a slice of South America, it is almost entirely a deep, dark ocean. In fact, there's a spot in the South Pacific where you can travel for thousands of miles without hitting a single patch of dirt. This area is home to the oceanic pole of inaccessibility, better known as Point Nemo. It's so remote that if you sailed there, the nearest humans wouldn't be in Chile or New Zealand. They'd often be the astronauts on the International Space Station passing overhead. It's one of the emptiest places on Earth, surrounded by thousands of miles of open ocean. Now, when sunlight travels 93 million miles and hits Earth, two things can happen. It either bounces off the planet and escapes to space, or it gets absorbed. That's because of the phenomenon called albedo. It works exactly like your wardrobe on a scorching day. Lighter surfaces act like mirrors, bouncing the sun away to keep you cool. Darker surfaces are like sponges. They soak up that energy and turn it into heat. Now, humans have actually figured this out on a smaller scale. If you didn't know, many traditional houses on the Greek islands are painted bright white. It's like a form of ancient air conditioning. The white paint reflects the intense Mediterranean sun and helps keep the inside cool. Cities are now trying a similar trick. Places like Los Angeles have spent millions of dollars coating black asphalt streets with a special gray surface to boost the city's albedo. By making the ground a lighter color, street surfaces can cool by about 15 degrees. Now, on a much bigger scale, planetary even, ice, snow, and bright deserts act like mirrors, bouncing back the light, while oceans are the opposite. They soak up the rays and store that energy as heat. So, according to physics, the land-heavy north should reflect more sunlight. The ocean-heavy south should absorb more. Meanwhile, when looking at Earth from space, one half should look brighter than the other. So for decades, NASA has tracked Earth's energy using a system called CERES, short for Clouds and the Earth's Radiant Energy System. These satellites measure how much sunlight arrives and how much leaves. This is how we learned that Earth is cheating around the albedo rule. Now, think of Earth's atmosphere as a giant planetary mixer, constantly pushing heat between the north and south to keep it from piling up in one place. According to the latest data, that mixer is starting to fall behind. When scientists looked closely at the CERES data, they saw a clear split forming between the hemispheres. The northern hemisphere is now holding onto more of the sun's energy than the southern hemisphere. Specifically, the north is gaining about 0.3 watts per square foot per decade more solar energy than the south. Yep, that sounds microscopic, but multiply that by every square foot of the Earth's surface, and you have a massive engine of heat that could make the weather unpredictable. Now, you would expect clouds to push back by reflecting more heat to space, but the data shows that the response hasn't been strong enough, so the extra energy keeps piling up in the northern hemisphere. Now, this is a big deal because heat is what makes the weather move. Hot air rises and pushes wind and storms around the globe. If one side of the planet creates more pressure than the other, those wind patterns have to shift. So it's not just that the weather is getting hotter, it's that it physically moves to new places. You've probably heard of the geographic equator, the invisible line running around the middle of the planet. But there is another equator related to weather. It's called the thermal equator. Think of this as a giant collision zone. Imagine pointing two powerful fans at each other. Where the airstreams meet, the air often gets forced upward, building what could look like a moving wall of rain. Scientists call this zone the Intertropical Convergence Zone, or ITCZ. It marks the planet's thermal equator. Sailors had a better name and knew it as the doldrums. They knew it as a zone where winds cancel each other out. Pirates in the 1700s were terrified of it. You could get stuck there for weeks, just floating, waiting for your drinking water to run out. The system acts like a planetary thermostat. It likes to hang out where the heat is. For most of human history, it stayed right in the middle. But if this imbalance keeps growing, it could nudge the thermal equator north over time. Now, you might be thinking, so what if the rain belt shifts a few hundred miles? Well, history gives us a pretty striking example. About 6,000 years ago, this rain belt sat farther north than it does today. At the time, much of what we now call the Sahara wasn't desert at all. It supported lakes, grasslands, wildlife like hippos and giraffes, and thriving human communities. Rock art from the region even shows boats and swimming scenes. As Earth's orbit slowly changed, the rain belt migrated south. Over time, rainfall faded, lakes dried up, and the landscape transformed into the Sahara we know today. The trigger was different, but the mechanism was the same. When the planet's energy balance shifts, the thermal equator moves, and the rain moves with it. This is a huge deal because rain is incredibly important for food production. It waters the regions that grow our coffee, our chocolate, not our chocolate, yep, and the crops that billions of people eat. If that belt chases the heat and moves north, the rain goes with it. The jungles in the south could dry out, while cities in the north would get hit with floods they were never built to handle. But the air is only half the story. Down at lower elevations, the extra heat triggers a chain reaction. Remember the t-shirt analogy? Much of the northern hemisphere depends on bright snow and sea ice to reflect sunlight away. But as temperatures rise, that low-altitude ice melts. When the white surface disappears, it exposes darker ocean water or bare ground underneath. This creates what scientists call a feedback loop. As the ice melts, it reveals the darker ocean or land underneath, and that dark ground absorbs more heat, which can cause even more ice to melt. It's a cycle that could make it progressively harder for the region to cool itself down naturally. Meanwhile, the oceans take their time responding. Global currents act like a giant conveyor belt, moving warm water around the globe to balance energy. But this system is delicate. It only works when the water's temperature and saltiness are just right. When the north hoards too much heat, it throws the currents off. And if the belt slows or reroutes, the effects don't hit overnight. They unfold gradually over decades or even centuries. But finally, is this just a temporary glitch? Or is the Earth settling into a brand new pattern? Right now, scientists can't tell for sure. Maybe the clouds will finally show up and fix the balance. Maybe the oceans will move the heat around and save the day. But if the North keeps gaining an energy advantage, the weather maps we rely on might change for decades or centuries. If that's the case, many places will have to rethink their daily life. Those not used to rain would suddenly feel cheated, while the value of raincoats, umbrellas, and white t-shirts skyrockets.